Okay, we're good. So I'm really excited today to have Dr. Cabrera with us to talk about his work in systems, and he definitely has been very active in using systems in all types of work. So I'm excited to hear all about that. If you have a question, just put it in the chat box, and we'll get to the questions later. Also, any references that you think of that you would like to share, because we'll be able to save the chat as well and share those references. So, Derek, I'm going to just turn it over to you. And if you want to give a little bit more introduction about who you are and how you've been using systems, that's the whole point of today anyway, so I don't want to be redundant. And so I'm just going to turn it over to you.
Sure, thank you. Thank you very much. And thanks, Deanna, for setting all this up and making this possible. I know it takes a lot of work to get everybody. So our work, Laura is not here today, but all of the things that we'll talk about, Laura's been instrumental in developing in our research lab and at Cornell. Our work is really in 3 different areas, and we're going to talk about 2 of them today. One is really globally, it's just systems in general, so systems science, but our focus is sort of on the cognitive dimensions of systems science, so systems thinking, and also systems mapping. How do you go from sort of the concepts to the mapping and visualization of it? How do you do it? And also systems. Our 2 books, which we use as graduate texts here at Cornell, are The Systems Thinking Made Simple and The Flock Not Clock, which is about systems leadership. So if you're interested in the systems leadership, which we won't talk about today, that one kind of goes more into that. And generally speaking, we've been very fortunate to work with a lot of different folks. We work with over, I don't know, probably 13 years ago, we took a graduate course, which was for doctoral students only, to do systems thinking in their dissertation topics. And Laura had the crazy idea of like going out and working with kindergartners. And we ended up doing over the next decade a lot of research and a lot of work with K through 12 at every level. And we ended up teaching them the same ideas that we were teaching our doctoral students. So that's something that we were very excited about, that you can teach little kids the same ideas, and in some ways they get them faster than the older kids. So we work a lot with executives. We work with faculty and academics and researchers and science. We work with policy level stuff at the Department of State. We work with the military, and like I said, we work with K-12, NGOs, nonprofits. So it really is a pretty diverse set of use cases that we work with, and yet there are patterns that connect all of them, as we all know from being in the systems community. So with that, I'll kind of start, and if you have questions, feel free to jump in, but we will have at the end a whole plenty of time for discussion and questions as well. And so today, really just going to hit on 3 very important questions, sort of basic questions. And those are: why systems thinking? What is systems thinking? And how do you do systems thinking? And that's what we call systems mapping. And not long ago, really about, I think 12 or 13 years ago, Laura and I had done a lot of research on why systems thinking, what's it for, and what is it. And we consistently were able to get groups to understand what it was and how it worked and all that kind of stuff. But we kept running into this problem of, well, how do you do it? You know, like a lot of people really want to know, how do you do it? How do you practice it every day? Can you practice it on little things, not just big things? Can you practice it on simple things, not just complex things, that type of thing? And so Laura and I spent a huge amount of our time trying to figure out, well, what are some of the ways that we could best do systems thinking and find out more about how people do it and things like that. So those are the 3 questions we'll hit on Before I jump into those, I should say that I didn't start off as a systems scientist. I started off as a high altitude mountain guide. And for nearly 2 decades, I spent over 200 days a year in a tent guiding clients up and down the mountains of the world. And really, it was in the mountains that I came to actually understand systems and the importance of systems thinking. I didn't even know that there was a term systems thinking when I was out there, but it became very clear why they're so important. As a climber, the summit of a mountain is basically an interdisciplinary problem to be solved. But to solve that problem, you have to understand the mountain and the expedition as a complex system of systems. So you have to understand the various systems around you as an integrated whole. And so there are numerous systems, of course. There's the systems of physics, like your technical gear and your rope systems and your rescue systems. And there's the external systems like the weather, the snowpack, the geography, and the geology. An old mountaineering mentor of mine used to say, he was fond of saying, mountains are just piles of rocks trying to get down. So that's what makes them quite difficult and dangerous. There's also, of course, the systems of biology and chemistry, your physiology, your hydration, your energy and metabolism, and especially the transfer of heat and moisture. The mismanagement of any of those things can lead to anything from the mundane, like headaches and dehydration, vomiting and sleep deprivation, to the severe, like hyper and hypothermia, frostbite, or high altitude pulmonary or cerebral edema. So we're constantly managing and analyzing those systems. And then, of course, there's the psychological or the sociological systems. So climbing is ultimately not really a physical game, but a mental game. So it's very psychological. But something that a lot of folks don't know, it's also a sociological game. Most expeditions fail because of conflict between people, not because of logistical problems or because of technical problems, but because just people on the mountain can't get along. So these systems are the context for the various decisions you make, and these decisions are often high stakes. You need to be adaptive, and these systems involve multiple subsystems across scale, much like the other types of systems that we deal with in business and in policy and in the environment and sustainability and things like that. So one of the things we talk about a lot is that we live in a VUCA world. This is a term that was coined by the military and is now used pretty widely in the private and public sectors. And it just stands for volatile, uncertain, complex, and ambiguous. And in this VUCA world, the question really that we have to ask ourselves is, how do we prepare ourselves for jobs that don't yet exist in industries that are being massively disrupted, with technology not yet invented, to solve unknown problems in a society we can only imagine? Those are some of the problems that a VUCA world throws at us. And the fact and the feeling that things are more VUCA, that things are actually faster, that things are more complex, and that the problems that we have are actually more wicked is really, if you think about it, the result of interconnections. The more interconnections we get, both physical, informational, social, all these different types of interconnections, that increases the complexity that we have to deal with. And we're not only more interconnected socially by the internet and the spread of ideas and news across global communications, we're interconnected physically and across geography. So a virus anywhere in the world could arrive in any other country in a matter of hours. So those are a lot of physical connections that didn't prior to this exist. And the physical virus itself need not be transmitted. So just the transmission of the news or the information alone can lead to massive global effects. So in December 2003, there was a case of a single mad cow disease in Washington state. And that led Japan, South Korea, and China to cancel $850 million of beef imports, leading to large-scale knock-on effects on the American economy. Likewise, the recent US recession of 2007 and 2009 showed us that this interconnectedness can have unintended consequences and even strange causal bedfellows. So a bunch of bad loans and home foreclosures in the US leads to whole countries going bankrupt and numerous other knock-on effects around the world. And of course, sometimes the solutions we come up with become the problems themselves. So because it's a problem that pests eat crops, we solve it by spraying pesticides, so that's the solution. But these pesticides leach into the soils, the streams of, in this case, this massive Mississippi River watershed, the pink area, and that all ends up in the Gulf, right off the coast of Louisiana there. And these nitrates create a dead zone in one of the world's greatest shrimping and crabbing areas. Meanwhile, there's a war in another Gulf that causes the price of oils to rise, which means that boat captains need to have even more money to get more fuel to go out to the shrimping areas beyond the dead zone. And that means, you know, you're going to pay more for shrimp at Red Lobster and things like that. So you can see that farming in Montana, way up near Canada, is related to lots of other things and systems and pesticides and what you're having for dinner. So the problem is that while the world is VUCA, volatile, uncertain, complex, and ambiguous, the way we tend to think about the world is often what I call it, and this is kind of a technical term, lame-o. And I mean that by linear, anthropocentric, mechanistic, and ordered. In a word, our thinking is biased in ways that don't match up with the way the real world actually is, and we project this bias onto the world, and as a result, often miss the critically important feedback that the world is giving us. So let me just give you a few examples of what I mean by this. The real world is nonlinear and includes feedback and webs of causality, yet we tend to think in very linear and causal ways. The real world is agnostic about human endeavors. We're pretty small and insignificant, yet we tend to look at things through a human-centered or anthropocentric lens. And our world sort of, we perceive our world, our brain is actually structured to perceive our world as if it's centered around us. The real world is multivalent by nature, meaning that and both solutions can be true. Yet our thinking tends to be needlessly bivalent or either or kind of thinking. And the real world is adaptive and organic. Yet we tend to think very mechanistically. The metaphors we use are good references to this mechanistic thinking in machines. The universe is like a clockwork, we say, even though the universe is really nothing like a clockwork. And the mind is like a computer, we say a lot, even though the mind is really nothing like a computer. And finally, the real world is networked and complex, and it also has a sprinkling of randomness, which is very important because even just a sprinkling can change the whole dish. It is constantly evolving, yet we think of things in ordered and static categories and hierarchies. So this mismatch is a problem. And if I were to compress all of systems thinking into a single Boolean cube kind of quote, I think this quote sums it up well, that wicked problems result from the mismatch between how real world systems work and how we think they work. So this leads to these giant hairball problems. This is a hairball, an actual hairball, or wicked problems. And Riddle and Weber in 1973 kind of coined the term wicked problems, and they hit on a bunch of different ways that these problems are somehow different. But a number of the things that they hit on is that they have multiple and fuzzy boundaries. They're highly interconnected. They have multiple scales that are relevant. Solutions can breed new problems. And sometimes the solution often can only improve a situation. You can't literally just solve it, but you can just improve it. And of course, there are many, many perspectives in these wicked problems. The context varies. You have decision makers that need to be responsive and adaptive. There are human costs, et cetera. So systems thinking asks us to look a little deeper than our typical fashion of thinking. Typically what we do, we're a little bit like this boat here, and we come along and we look at superficial events and as a result react to them. And what systems thinking asks us to do is go a little deeper and look for systemic patterns. Repeating events. And when we do that, we can predict, which can give us precious seconds or minutes or days or weeks to start to respond to those events. But if we go even deeper still, we see that system structure actually determines behavior. And this is a very important systems principle, that system structure determines behavior. And that is that the way that systems are organized will actually determine their behavior. So if we don't like the way that a system behaves, we can look at its system structure. And when we learn to see these underlying system structures, we can not only react and predict, but we can begin to design and leverage structures to bring about the desired behavior. But systems thinking really wants us to go one step deeper, which is to look at our inherent biases in the way that we frame our mental models. And when we acknowledge and challenge these mental models, it allows us to see ways to totally reframe the event and see it in a different way. In other words, as Einstein said, we cannot solve our problems with the same thinking we use to create them. The problem has been that prior to deeper studies in neuroscience and cognition, we didn't really understand how mental models were built, nor how they aligned with the real-world system structures. But today we actually know quite a bit more about mental models and biases with the advent of neuroscience and cognition, which were sciences that weren't even around when the field of systems thinking and system sciences began. So as just one example of the many types of bias, there's over 200 informal biases. There's about 80 research biases that infect our mental models. Confirmation bias is kind of a big one. And this one is really important. This is kind of my favorite cartoon that represents confirmation bias. They think that the goat is up in the cloud bank. And confirmation bias is such a remarkable bias because what it actually does is the opposite of systems thinking. What it does is it filters the real world information to fit our mental model rather than to fit our mental model to the real world. So confirmation bias fundamentally is the opposite of systems thinking. It is the act of fitting the real world information to our mental model rather than fitting our model to the real world over time and evolving it. So for those of you where mental models are somewhat new, I just want to give a few examples of what we mean by mental models, so we get a sense of what they are and also not just what they are, but how ubiquitous they are, because they are literally everywhere all the time. Here's an org chart mental model of the modern organization. This is kind of how we think a modern organization works. It's a hierarchical structure, etc. But of course, this is probably more like how the system actually works. The systems may have a hierarchical or top-down formal structure, but they also have and operate as an informal and dynamic network of influencers and influences. And this video really captures, again, how pervasive mental models are, and also how important it is to test them against reality. So the only mistake he made there is he probably should have let the other guy do the testing. But other than that, that's a good example of mental models and testing them against reality. But I want to make clear that mental models are not just these things that sort of exist. You know, we think of them just existing in our head. They actually, the manifestations of them exist all around us. If you walk into any classroom, the structure of the classroom is a mental model, somebody's mental model of how learning should happen. And it may or may not be accurate, the way that we set up classrooms and the way we design them based on those mental models. Barbie is a fantastic example of a mental model that has been wildly influential. And if you have teenage daughters like I do, you know that Barbie has had an enormous impact on their mental models of themselves and their proportions. A new doll named Lamely uses scientifically accurate proportions of the average 19-year-old woman, as indicated by a CDC report. But what's important to understand is that Barbie is not merely a rare or improbable occurrence. She's literally a unicorn. Barbie's proportions wouldn't allow her to stand up anatomically. Her head is so large and her neck so long and narrow that it would not support the weight of her head. We would need to remove some of her ribs to make room for her internal organs. And as one example, Lamely has a shoe size of 7.5, whereas Barbie is a shoe size of 3. And women's shoes in the US don't even come in a size 3. So Barbie is a mental model that is completely unreal, and yet it's a mental model that influences whole generations of people. Recently, we heard news of 2 women, First Lieutenant Shay Haver and Captain Kristen Greist, who have altered the collective mental model of what it means to fight like a girl when they passed Ranger School. And in speaking a lot with military leaders and things like that, as far as mental models go, it's now widely acknowledged that our tendency in war fighting is to fight the newest war with the mental model of the last or previous war. And today's military leaders focus early on organizational learning to adapt their mental model, which they assume is already outdated, as quickly as possible using a testing, learning, and fail fast approach. So the answer to why systems thinking is really, at a simple level, really because reality is VUCA, and we need our thinking to be more VUCA friendly. Our thinking tends to be kind of linear, anthropocentric, mechanistic, and ordered, making our mental models wrong quite a bit. And a lot of that comes from our inborn and structural biases. And this mismatch breeds all kinds of wicked problems that are not necessary. So that takes us to what is systems thinking as a question. And as a summary, before we get into that, I'll just say that it's a DSRP process. It's a process where you interrogate and constantly evolve your mental models to align with reality. So the statistician George Box explained that all models are wrong, but some are useful. Mental models are constant approximations of reality. They're not reality itself. And we know that our mental models are often wrong, they're biased, and so we have to test them. And as an example of this, Ptolemy, he came up with a mental model, which was that the Earth was, anthropocentrically at the center of our system. And Copernicus built on this mental model and kept most of the things the same, but changed what was at the center. And it's important to understand that as these mental models evolved, we were able to do more things. Even Ptolemy's model, which was wrong, was a better approximation of what we had prior. And Copernicus came along and evolved the mental model. And then Kepler came along and said, "Yeah, well, Copernicus, you got it kind of right, but they're more elliptical orbits, and Pluto kind of misbehaves a little bit," and things like that. So mental models build on each other and they evolve, and they're never perfect, but some are better than others. So that brings us to sort of the crux of systems thinking itself, which I just call the systems thinking loop. It's a very simple concept, but incredibly profound. The basic idea is that we observe the real world, we build a mental model, we test our model against the real world, and we get feedback in the form of information, and then we start the loop again, interrogating and evolving our mental models. And it's important to understand that we go around this loop over and over again, and as we do, our mental model gets better and better. Most of the big ideas today in organizations, design thinking, agile, lean, all these different things that people are doing, they very rarely are based on the basic systems thinking loop, which is this idea of mental models growing and evolving until, over time your mental model gets to be a better approximation of whatever slice of the real world that you're analyzing. What's super important, and this I think is where systems thinking can benefit from the last 50 years of research in the cognitive sciences and neuroscience and the brain sciences, is that the crux of systems thinking relies on the interrogating and evolving your mental models, which is a part of this feedback loop. And it becomes very important to understand precisely what mental models are made of. And it turns out that they're made of two things: information, which is coming from the real world, and thinking. And those two pieces are critically important. Information is not the same as knowledge or understanding or meaning. It is simply the data or the content that's coming from the real world, and then we use thinking to organize it, encode it, understand it, make meaning of it, etc. So thinking can be thought of as structuring, organizing, encoding, any kind of thing. We call it cognition in science, but generally speaking, people call it thinking. And that leads us to this very basic equation, which essentially says that mental models, which you can think of as synonymous with knowledge, ideas, concepts, or meaning, is equal to information, which is the same as data or content, and thinking, which is the same as cognition, structuring, encoding, organizing information in various ways. And so the question is, how are we organizing information? What are the ways that the brain organizes information in order to make meaning of it? And so that makes the T sort of a fundamental thing that has to be understood by systems thinking. And it turns out that the way that we do this systems thinking or this thinking of organizing of information is through 4 fundamental patterns of thinking. And those are, I just call those DSRP. It's just a silly acronym. I wish I had named it something different many, many years ago, but the name is stuck, so it's called DSRP now. Sometimes we call it for the patterns of thinking or metacognition. There's a lot of different names for it, but DSRP just stands for distinctions, systems, relationships, and perspectives. And each one of those patterns has 2 elements that interact. And of course, the 4 patterns completely interact and mix and match together. These are universal. You don't need to do DSRP. You're already doing DSRP. You can't make it out of bed in the morning without making distinctions. You're always taking perspectives. You're always grouping ideas into part-whole systems, and you're always interrelating ideas. That's just something we do. It's what our brain does. So it's not really a matter of doing DSRP. You're already doing DSRP. It's more a matter of being aware of how you're DSRPing, and that awareness can help with becoming more systemic in your thinking. So what I want to do is just go through each one of these and sort of show you how they work, and more importantly, not how they work individually, but how they work together. So we're going to start backwards and start with perspectives, because the real world is perspectival. Different objects or organisms or elements have their unique perspective on the world. And even if the perspective itself is imaginary, meaning somebody's making it up, it has real world effects because it changes behavior, and behavior changes the system. So we have to understand that first and foremost, we as humans are one big biased perspective taking organism. And you cannot not take a perspective. You're always taking a perspective. So what are perspectives and how are perspectives important to you is a critically important understanding of systems thinking. We have to understand what they are, how they're structured, when they are, which is always, and how they play themselves into importance. So we'll talk a little bit about perspectives for a moment. I don't know if you heard this, but turtle crime in the United States, at least, is way up. The other day, a snail was mugged by a gang of turtles, and when the police arrived on the scene, they asked the snail what had happened. And the shaken snail said, "I don't know, it all happened so fast." I can't hear your laughter, but I'm sure you thought that was a funny joke. You probably thought that very quickly, that it was a funny joke in milliseconds. And what's amazing about that joke, aside from being incredibly funny, is that your brain understood it in a matter of milliseconds. And in order to do that, your brain had to take 3 perspectives without your permission. It had to take the perspective of snail speed, turtle speed, and human speed. And if you're not able to compare and contrast and relate those different perspectives on speed, then the joke isn't funny. Your brain did that without your permission and in milliseconds. So perspective is occurring all the time, whether you like it or not. One question that you could ask yourself is, can you imagine what it would be like if you couldn't take perspective at all, if you literally couldn't take a perspective? And in fact, up until you were 4 or 5 years old, you just took one perspective, your own. And that's for evolutionary reasons, to protect little kids from, certain death if they didn't mostly hyper-focus on being self-centered. So self-centeredness at a young age is incredibly important, actually, for survival. But then, as you develop beyond the basic survival stage and need to become more of a social animal, perspective becomes even more essential. And the Salient experiment are the origins of advanced perspective taking in what is sometimes called theory of mind, or TOM. And I'll just walk through what the Salient experiment's about. A researcher sits with a child of various ages and walks them through the following scenario. So the first is that they say, this is Sally. They do this with dolls and an actual basket and an actual box. They say, this is Sally, and Sally has a basket that has a cover. And this is Anne, and Anne has a box that closes. And Sally has a marble, and she walks in and she puts her marble in the basket. And then Sally goes out for a walk. And Anne's a little troublemaker. She takes the marble out of the basket and puts it into the box. And she closes the box and closes the basket. Now Sally comes back in the room, in the scene, and she wants to play with her marble. And the question that is asked of the 3, 4, 5-year-old children or 2-year-old children is, where will Sally look for her marble? Now, as adults, we will say that Sally will look for her marble in the basket. But it turns out that with kids that are 2, 3, 4 years old, they will say that Sally will look in the box. And the reason for that is they're not able to take a theory of mind or a perspective of Sally as different from their own. So the kid knows that the marble's in the box, so that's where Sally would naturally look for the marble. But knowing that Sally was outside when this transition happened of the marble, we know that Sally will look where she put it, because that's where Sally's mental model is. Well, around about 4 or 5 years old, kids start making this perspective shift, and they're able to take perspective or theory of mind of another person or persons. So perspective is incredibly important. It's actually at the base of empathy and compassion. We can't be empathic or compassionate without perspective. So this actually leads us to realize that systems thinking is not just an analytical sport, but is also deeply embedded in emotional intelligence and other very important skills. And of course, no matter what the issue or subject is, no matter how insignificant or profoundly important the topic, there are different perspectives on it. So much so that you can write whole books on the topic. Perspective it's important that you can't not take a perspective. Your mental models are a slice of reality, and even within that slice, they're still an approximation. That means no matter what you're thinking, doing, taking in, you are taking in a perspective, which is why systems thinking requires us to identify the salient perspectives that are causing us to make the distinctions or the systems to organize things in the way we do, or to see or not see the relationships that we see. And just to give you a few short takes on the importance of perspective, Marcus Aurelius said that everything we see is a perspective. Steve Jobs said that basically running a company is about taking your customer's perspective. So deeply understanding your customer's perspective is the epitome of success. And Lao Tzu talked about knowing your enemy, and you have, in order to do that, you have to sort of become deeply and take their perspective. So whether you're talking about succeeding in business, succeeding in life, succeeding in conflict, whatever, perspective is incredibly important. So the question is, despite the very many perspectives that are out there, do they have a similar structure? And it turns out that they do. They have a very similar structure, and I'm going to show that to you in this example. So we could take an optimist and a pessimist as perspectives on a single glass of water. And this is a map done in Plectica software, which I'll show you later. And we can see that the optimist sees the glass of water as half full, and the pessimist sees it as half empty. So let's zoom in on what's going on here. We have a point in the optimist, and the view is the thing that the optimist is looking at. So we have a point structure and a view structure. And together they make up a perspective. A lot of people confuse that the perspective is the same as the point, but the perspective is actually the relationship between the observer and the observed. Now, in this example, we also have another point and another view, and together those make up another perspective. And so together we actually have, in this very simple example, several variables that have to be accounted for. You have 2 point variables, 2 view variables, and those together make up 2 perspectives. And if you change one or the other, you change the perspective. So there's 4 important variables. And of course, in this situation, we could think of it in many, many other ways from many other perspectives, right? So even something as simple as a glass of water, never mind a complex political system or environmental system that has many perspectives, just this very simple glass of water can be looked at in a lot of different ways. But the point of that is that all these different types of perspectives are based on the same underlying structure, which is that they're a lens on the world made up of a point and a view. And I want you to think a little bit about these 2 variables, point and view, a bit, and ask yourselves, what can be a point and what can be a view? Does the point of view always have to have eyes, for example? Does it have to be a person or a frog? It turns out that humans are very good at taking perspective from things that have eyes. So we can take the frog's perspective. We can take another human's perspective. But we also take many, many perspectives that are not with eyes. So do points have to be people, and what other kinds of points can there be? As an example of that, I give you this list, all of which can be perspectives. We can take an economic perspective, which is not a person, it's a concept. We're literally taking a perspective from a concept. And in that, not just a concept, but a whole system of concept. We can take a historical perspective, a health and safety perspective, an emotional or security perspective, a cultural one, a legal perspective, an ecological or political or moral, ethical, social, or technical perspective. All of those things and everything else can be perspectives. So my question to you is, could something as simple and pedestrian as toothpaste or toilet paper have a perspective? And it turns out that even things like that can have a perspective, because in order for the comedian to create this little comic strip, he or she would have to take the perspective of those inanimate objects. And perspective is critically important whenever we're analyzing systems of any kind. And I'll just give you one example of looking at a terrorist network. Here is up at the top, we're seeing how this network can be analyzed from non-human perspectives. So this is the perspective of that these folks who attacked in groups, folks who lived in Brussels, from the perspective of Moroccan descent, from the perspective of committed previous crimes, from the perspective of previous terrorist ties, or shared apartments, or visited or tried to enter Syria. And based on those perspectives, we can analyze this network and see different patterns and organize the network differently based on the perspective. So you can see already that the distinctions change, the systems of the way we group things and what exists changes, and even the relationships change when we change the perspectives. But consider this about perspectives. Perspectives can be wrong. Indeed, they often are, or at least they're incomplete. So why is it important to take a perspective that we know is wrong? Each of the terrorists in this network have a perspective. They know things and they don't. They know other people and they don't. They don't have a God's eye view of the system. They have their limited view of the system. And yet, even though it's not a God's eye view, it is as a result, it's not correct technically, and yet it is affecting their behavior and therefore affecting the system. So when we do a systems analysis, even taking wrong perspectives is critically important to understanding the behavior of the system. So, in fact, no matter what kind of network you're talking about, the perspectives in the network matter a lot, even if they're quote unquote wrong. So whether you're talking about an abstract mathematical network or a political network, a food web, organized corruption or Yellowstone ecology, a computer network, a business network of conglomerates, a disease network, a linguistic network, terrorist network, dating network. That one at the bottom right is a human trafficking network. No matter what kind of network you're analyzing, the perspectives matter to the behavior of the network. And so, like I said, one of the things that Laura and I have found in doing this is that the being able to map it is critically important. So we're going to show you some of the software and how it maps these problems. In this case, we're talking about a problem that increase in out-of-wedlock births, or OWBs, and we're asking what is that relationship between the Personal Responsibility and Work Opportunity Act, which is an actual policy that is developed as a result of this problem. So we can ask those kinds of things. And basically what we're doing is taking perspectives, and we're asking ourselves, what are the salient perspectives? In this case, some of the salient perspectives are economic, political, social, as well as unwed mothers and unwed fathers. And that creates a perspectival circle around the issue or problem. And we'll get into more about how those perspectives play themselves out. But first, we have to distinguish which are the most important perspectives. And here's an example of taking just two of those perspectives, a conservative and liberal perspective, on the actual act itself. And we can see that the different parts of the act, the different elements in the act, actually are seen differently depending on the perspective that you're taking. So the conservative perspective sees the red conservative views of these objects, and the liberal perspective sees the blue liberal views on these objects. There's two objects where they agree, which is in purple, but on the rest of it, they disagree dramatically. And so this is an example of perspective taking in mapping that allows you to really get into how these perspectives play themselves out. Perspective changes everything, and we often say that when you change the way you look at things, the things you look at change. And that is incredibly important, because the things that are changing are the distinctions, the systems, and the relationships. So now we'll jump into distinctions, where your brain is constantly making distinctions, and you can't not make distinctions. The real world also has some, but alignment between them is pretty critical. Your distinctions are plagued with your biases because they're developed from your perspectives. And when you make a distinction, you have to pay attention to those, because they kind of, like if I poured poison into the origin of the Nile, everything downstream will be affected. The distinctions that we make right away are things that will constantly plague us through our analytical processes. So refining your distinctions is incredibly important, and challenging, especially popular distinctions, is incredibly important. The perspectives we take change the distinctions we make. This is a great understanding of that, where you have the purple side and the distinctions they make. And then, for example, if we switch sides, they would switch all the distinctions that they make. So the distinctions that we make are based on the perspectives that we're taking. And you probably, if you've been in systems for a while, you've probably seen this little cartoon, which is absolutely brilliant. There can be no peace until they renounce their rabbit god and accept our duck god. This is about distinctions. This is about perspectives. This is the kind of stuff we go to war over, because we don't take perspective and see distinctions that are being made. And of course, this would be terribly unfortunate for both parties. And if you're working in organizations, you know that there are many different perspectives that change the landscape of the elements, the distinctions that are involved, and those kinds of things, the way the customer sees it versus the way the project is, et cetera. Just to give you an understanding of just how important distinctions can be, this is a differentiation that the superintendent of West Point, where we work a lot, is. West Point is the military academy here for the Army, and the superintendent made these following distinctions. The West Point does not educate students, it develops cadets. It is not a college campus, it's an Army base. The cadets do not live in dorms, they live in barracks. The West Point dorms are not run by resident RAs, the barracks are led by tactical officers, TACs. And West Point is not a university, it's a military academy. So those seem like very simple distinctions, and yet you can see how the organization as a culture would develop. And if you're familiar with chaos theory with original starting conditions, those distinctions will lead to very, very different organizations based on just the starting condition of those. And of course, this is a whole group. We make distinctions all the time in milliseconds in our brain, but here's an example of it being made at a social context over years. A single distinction being made, what is a planet? In Prague in 2006. And these are the top planetary scientists in the world discussing a single distinction, what is a planet? And this is the moment when they voted Pluto off the island. Right? So again, so distinctions are being made socially across large time spans. They're being made psychologically across minuscule time spans. And you might look at this and say that if you haven't seen it before or know the secret, the one orange circle on the right is bigger than the one on the left, but of course it's not. It's exactly the same size. And the question is, how does the identity of that distinction come about? How does one circle look bigger than the other? And the answer is it's because of the others that it's with. So distinctions is made up of identity and other. So the distinction is the line, the dividing line. This is Mexico City. The distinction is the dividing line between identity and other. And you can imagine that we could label these identities and others very differently and end up with very different things. So for example, that could be the identity and other, or that could be the identity and other, depending. And we could label this rich and this poor, or we could label this hardworking and not hardworking or entitled. And based on those distinctions, we could end up with very, very different conclusions. And this, of course, plays out in all identity formation, whether it's the identity formation of birth order and siblings, or whether it's the identity formation of companies and brand identity. We're constantly creating our identity based on others. And so distinctions is about whether or not we're marginalizing others. And this happens at the cognitive micro level. If I tell you not to think about an elephant, you have to think about an elephant. And if I show you this T-shirt, which is one of my favorites, your mind naturally thinks about number 2. Your mind does that without your permission. It's just the way your mind works. When you identify things or ideas that are important, you have to consider the alternatives or the other, or you may pay for it later on. And importantly, pay particular attention to the most common and accepted distinctions that people are making. If you're familiar with organizational structure, these are a great list of distinctions that Peter Drucker, who's very famous in that realm, OR and stuff like that, make. And these are the kind of distinctions that matter. So, we're constantly making distinctions, but in the case that we're going into of non-marital births, what are some of the salient distinctions? First, what does non-marital mean? Which is more reliable, rates or proportion? Rational choice models versus biological cause model, deficits models versus asset models. Is hope relevant? It turns out that it is, but not something that you would initially make a distinction of. And linear causality versus webs of causality. So we can map these by creating cards for the distinctions that we think are important. So as we zoom into distinctions, we can understand that we can make a very generic distinction like bird, but then somebody or a whole group of somebody's come along and refine that distinction. So each one of those birds is further distinguished. But what you'll notice is something very unique and interesting about the human brain, which is as we're distinguishing, which is separating all these things, we're also grouping them, because the human brain groups things. So we distinguish things, we say these things are not like each other, but then we group things, we say they are like each other. So in the case of the owls are birds, but they're not also birds that are not like these other groupings of birds. And that grouping itself is a distinction, but it's also a part-whole grouping or system. So that brings us to S. And what we want to do with S is understand that a systemic view requires multiple perspectives to see the part-whole structure. And your brain is grouping stuff all the time. It never doesn't group stuff. In fact, you've probably seen this as a systems person. Basically what this is different perspectives, seeing different parts of the system, and nobody bringing all the parts together. This is a great example of how the system that we care about, the whole, which is the cartoon itself, is made up of many perspectives that see many part-whole systems that collectively bring about the whole system. And of course, these systems are occurring across scale, vertically and horizontally, as part-whole structures in the universe. We often say there's two types of scientists, splitters and lumpers. Splitters are kind of those reductionists that break stuff down. Lumpers are people, synthesists, who put stuff together. Early systems thinking wanted to pit these two against each other, Bertalanffy style, where we were holists but not reductionists. I think modern systems thinking embraces a new kind of person rather than splitters or lumpers, somebody that is ready for the 21st century VUCA world that I call a splumper. We have to be both. We have to be splitters and lumpers. We have to look at the part-whole detail, and we have to look at the whole structure together. So these things are not actually in conflict. And we often talk about Misi-Nong. I'm not going to go into that today, but Misi-Nong is just making sure that you have all the pieces and no gaps and no overlaps in your system. So all the parts, this is a system idea that you get no overlaps or no gaps, or mutually exclusive and collectively exhaustive. So going back to our example of the out-of-wedlock births, we look at the relationship here between these two things. And here's a great example of the Plectica mapping in context, all the different complexities and levels. You can see that yellow bit is what we just looked at, just this single relationship. But then that blows up into multiple layers and subsystems and systems inside of systems going downward. So this allows you to see the forest, which is the big picture, and the trees, and not only the trees, but the leaves on the trees and even the molecular structure of the leaves in any given system. And this is very important in systems thinking, is that you're able to compress systems to their smallest part. So you can see a single relationship between two elements, but then that can blow up into multiple subsystems with subsystems, and you're able to map all of that and see all of that. Or, for example, this is a subsystem made up of three little interrelated things. Why do women have children out of wedlock and things like that? I'm going to skip through this because we're running out of time here, but there's a lot of, yeah, I'm going to skip all this. So finally, our perspective shapes the relationships we see or fail to see. And again, your brain makes relationships, whether you like it or not. If you study Neuro Marketing, which is a new field of neuroscience and marketing, the whole thing is about being able to manipulate people to buy things by using their brain, what their brain does naturally. What does their brain do naturally? It makes distinctions of identity other. It makes relationships if we help it make them, even if they're wrong. It takes perspectives if we help them. It groups things. So neuromarketing fundamentally is utilizing this awareness without the person's awareness to get them to buy things. People make relationships all the time. Some of them are good. Some of them are strange. But those relationships you've heard of probably the example of in the 1950s, the World Health Organization sprayed DDT, and you can see how the DDT leads to, in order to get rid of malaria, but ends up causing tuberculosis and, the plague, and as a result of the different relationships. This is an example of unintended consequences and feedback loops and webs of causality. The relationships matter quite a bit in whatever system that we're looking at. But most importantly, not just the relationships, but the distinguishing the relationships. So a map like this where there's lots of relationships, but we don't know what they are, is not good enough in a systems analysis. We need to distinguish those relationships. This is Disney's map prior to creating the company, Disney. And Edward Tufte, who is the Da Vinci of information science, says, we think verbs are interactions, then show verbs and interactions, and annotate the linking lines. That is the equivalent of saying we have to distinguish our relationships. So we call this in DSRP language relationship distinction, or RD. But not only that, but we have to systematize those relationships. So we have to RDS, relationship, then distinction, then systematize. Because these relationships is where the hidden variables are in systems. So you can see this very simple example, the rear cassette of a bike, and the chain ring has the chain, but of course the chain is made up of many parts, even though it's also a relationship. Or you can look at the 25 million coffee farmers and producers and the 500 million coffee consumers. The relationship between them might seem like just a relationship line, but it's actually a whole complex system made up of 4 traders, 3 roasters, and 30 grocers. And there's obviously tremendous complexity even inside of that. And so we can map all those things. Here's an example of the global dynamics in the Middle East from a US perspective. Notice Russia is not on here as a distinction. China is not on here as a distinction. So it tells you what the perspective is. And we can see whether they're friends, enemies, and complicated. We can then zoom in Plectica to any one of these relationships or people or perspectives and see things. Maybe we want to zoom into that. It's complicated with the Palestinian Authority and the United States, the yellow line. And we can zoom into that as what's called a barbell, because it looks like a barbell. And then we can zoom into that and ask questions about what are the parts and the relationships that make up the system of that relationship. So it not only gives us a language for understanding this, but it allows us to make structural predictions about what will be there in the information. And going back to our example of out of wedlock births, what is the relationship between sexuality and rationality? And that informs the economic, political, and social perspectives on the issue, which is an increase in out of wedlock births. And it turns out that there's a huge disconnect between this, because it turns out that, and this is the RDS of that, depending on your model. So we're going to zoom into that RDS there that's coming out of the relationship. And if we zoom into that, what we see is that this policy was almost entirely built on a standard rational model where people do things rationally. And of course, this is being tested quite a bit, that people don't do things rationally. And one of the things they don't do most rationally is have sex. And partially a biological model will help us understand that, because really the cause of sex is hormones. And that is leading us to do certain things. So if we build an entire policy decision on a standard rational choice model, we're going to get the results that we get. So this is an example of when we zoom back in on that relationship between the issue, which is the increase in out-of-wedlock births, and the policy, which is the thing on the right. And we zoom in on that relationship as an RDS, a relationship distinction system. We see that this issue is so difficult because it is the central crux of religion, science, morality, and politics together. And that if we take a rational choice lens or a deficit perspective, we end up with the current policy that we have. But if we take a human development lens or an asset perspective, which includes a biological model, we see that there are opportunity costs and the lack of hope for women that should be a part of that policy, but is not. And so the two takeaways, we can't go too far into this. This is a whole dissertation topic. But the two takeaways that you get are that a rational choice lens versus a human development lens was used to draft this bill, and that the most significant variable, which is out of wedlock births, women's hope, that should be a W, not a man, is and was not considered in the drafting of the bill. This is critically important because there was a time in systems thinking where we tended towards thinking that a systems thinking analysis got us a big picture view. And that is true. It does get us a big picture view, but it also gets us the detail. And in that detail, we can find the simplification of the system and leverage that simplification. So it's not just about getting more, it's about getting the right parts of the system right. And it turns out that these two critical takeaways are the crux of why this policy went in the wrong direction in terms of the science behind it. So I'll wrap up there and just say that what I hope you understood there is that systems thinking is made up of these four patterns of thinking, and that they mix and match, that they're very dependent on each other. They don't occur separately, they occur simultaneously, and they compound each other. And second, that systems mapping, or being able to visualize in the Plectica software or whatever software, is incredibly important to doing systems thinking. So you can understand the concepts, which is something Laura and I struggled with for years. We could get people to understand the concepts, but then they'd go back to their jobs and they wouldn't know exactly how to apply them. And systems mapping is really the way that you can apply them. And it turns out that our brain has more neuronal connections to the hands and to the eyeballs than any other part of our body. So the reason that we use systems mapping or visualization is because it's object-oriented, meaning hands, and visual, meaning eyes. And that allows us to see more of the system and better understand the system. So it becomes incredibly important to do systems mapping in order to understand systems thinking. So we'll wrap there and then just open it up for questions. I'm sure you have lots of questions.
Yeah, the chat box has been quite active, so I'm sure that somebody's out there that has questions. So let's just remember that you're muted, so unmute yourself and let's go for it.
I'm not sure how to see the chat box. Is there?
If you just sort of hover at the bottom of your screen, you'll see chat.
And if you unshare your screen, oh, there we go. All right.
Yeah, there you are, Jim. You're up first, I guess.
No, I'm not. I just wanted to see us all in a group here.
Oh, got it.
Okay, I have a question. This is Gemma. Thank you, Dirk. This is a fantastic presentation. It was really mind-opening, a lot of overlapping with my work. It just so happened that I started to read the book Predictably Irrational yesterday from the behavioral economics. So several of the graphs you showed is in that book as well. So I wonder how you see the connection between your work and the behavioral economics.
There's a massive connection, and Kahneman's work on System 1 and System 2 is incredibly relevant. System 1 works very well when we're making quick decisions. And it worked very well evolutionarily for a long time for a lot of reasons, mostly because the detail didn't matter too much. If we could satisfy, as Herbert Simon would say, nature uses satisficing models, which is meaning, you know, if you can get it 60 or 70% right, then you're good. And for most of our evolutionary history, when we were hunting things on the plains, that worked pretty well. But today we need to get more things right, and that's where the System 2 needs to come in. And System 2 fundamentally is systems thinking. It's a more analytical, it's a more aware, more metacognitive way of thinking. And when you have to get things right, when 60% or 70% right isn't good enough, then you have to start using that System 2 thinking and systems thinking and things like that. So it's absolutely a huge overlap.
Would you say both are kind of stemming from chaos and complexity theory, this new realm of thinking about human behavior, rationality type of thing?
Well, I wouldn't say they stem from those because those things came before behavioral economics and things like that. So behavioral economics is giving us new tools to go deeper into things that we've sort of known for a while, but we didn't know why, and we sort of scratched our heads. I think a lot of these, like systems thinking from Bertalanffy on, and like behavioral economics and things like that, those are attempts to sort of get science to do itself better. And so we're saying, you know, if we use this rational economic model, we're going to end up with the kinds of results that we've been getting that don't work. And so maybe we got to change tune. Or if we use an overly reductionistic model, as Bertalanffy really pointed out in GST, then we're going to get a lot of stuff that doesn't work. We're going to get decontextualized linear models and linear causalities that are decontextualized in science, and we're going to think certain things are true, but then when we apply them in the real world, they don't end up being true. So I think a lot of these things are a pushback to modern science to sort of say, hey, we can do this stuff better. We can do science better.
Thank you.
Yeah.
Next.
Hi, can I ask a question, Derek?
Yeah.
Yeah, thank you for the presentation. It's very good, and I still have very confidence in how you do what you say in the end, the system mapping. I think.
Thomas, can you get a little closer to your microphone?
Yes, I think the essence of your theory, which I find is very good, is the system mapping. So you've got this DSRP structure. I use the word structure, okay, and then you can actually go, no matter how deep you go, microscopically, or how far back up macroscopically. The good thing is that you still have this exactly the same number of structure, the DSRP anywhere.
Yes.
So you can go deep in the system, just like what you have just the example you used, the bicycle, the relationship is actually have got this parts as well.
Yes.
So because I have only seen the what you have gone through and what's in the book, I haven't seen a real example, a detailed example, just like the example of the bicycle. You can go deep and you can go really big, but when you are trying to analyze a particular problem, how deep you go with a mapping, or how far back you go with a mapping, in order to not to lose your original intention of solving the problem. You can try to understand things. You can go into the part of the relationship, the length, the relationship of the bicycle length, and then you can analyze the part. You can go and analyze the particles. You can analyze the quantums and the quarks in there. But then, how far deep you go before you actually lose the whole picture or the original intention?
Yes.
Is there a rule of how far deep you go and how far back you go, and how many relationships and how big the mapping, in
Yes.
order to have a effective analysis of the problem with the original perspective?
Yeah,
Okay,
that's
so
that's a great question. It's a super important question. It's the question that our graduate students almost always ask, and it's one of the places where they have the most trouble. And what's really great about we call these things stopping rules. What are the stopping rules? Where do you stop? Where do you stop going down? Where do you stop going up? Where do you stop going left, right? You know, at what depth? When do you stop? How do you know when to stop? And of course, in systems thinking and in lots of other systems thinking, it's critically important to move away from, I think, the paradigm that there is a stepwise process. Because nothing that needs to be as complex as systems thinking is going to be given by a single stepwise process. But what's critically important to understand is that, like you said, these 4 rules are fractal. So they're happening at every moment, all the time. They're fractal. They can happen at any level. And the stopping rules are actually caused by those 4 rules. And in particular, they're caused by perspective. So when we create a perspective, a lot of people think of perspective as being something that expands your analysis, right? We take perspective, we take more perspective, that expands your analysis. But perspective can be a very valuable tool in limiting or contracting your analysis. You can use a perspective to say, let's only look at this stuff from this perspective, and that will limit the amount that you take in. So your stopping rules have to be determined by your limiting perspectives that are causing you, that you decide what they are based on the problem that you're dealing with. And no stepwise process is going to know how to give you that. It'll be determinate based on the actual problem that you're dealing with. And you'll have to come up with perspective framing rules that say, I'm going to allow myself to stop at this point based on this identity other distinction. And I realize that that cuts out an other or marginalizes an other. I'm going to make note that I'm marginalizing that other, and I'm going to have an audit trail for going back to figure it out if that becomes a problem. But generally speaking, this is where I'm going to stop based on this rationale. And there really isn't a silver bullet for it, but it is contained in the DSRP, and it's mostly in perspectives.
I have a question.
Yeah.
Derek, so when you create a systems map, often with the intent of influencing a group of behavior or a collective, you're using the map to provide that different view of the world. So what have you found about people's involvement in building the map with you? How important is it that the people who are affected, the collective that is affected, contributes in building the map? And what do you do when the information that they see, they're not ready to absorb? Or if you're trying to use this map to influence other people who haven't been building the system map with you?
Yeah, great question. I mean, clearly it's very important to involve people. In Plectica, I can show this. I also posted some example maps there so you can see in the chat, but I'll share this window here so that you can see this map. And I'll show you how we deal with this, where a few people get on with me. So we can build a map. Okay, so you see these people here, they just got on with me. Can you guys see that? So I can be typing here, whatever it is, and and other people can be co-building the map with me, and I can drag this part in and create another part that's me creating. But while I'm creating, some other people are creating over here, and you can see them up in the right-hand corner who's with me, and you can actually see by hovering over what they're creating. And that allows people to create maps together in collaboration. You can have as many people as you want. It is incredibly important for us to think collaboratively as well as just, in our own private Idaho kind of thing. So that's your first question. Your second question, can you get to the second part?
So these folks that are building the map with you right now are negotiating viewpoints, perspectives, and so forth with each other.
Yes.
But all the people outside that you still want to affect are not part of this process.
Yes.
The mapping software allows you to at least explain in richness what you're seeing, and you can start to have a process around that. But I'm just wondering to what extent the process of building and making sense of the maps is part of your process.
So that brings up a hugely important organizational point, which is you always have this infinite regress problem, which is you want to include everybody, but of course new people come and other people go, and you're kind of this dissipative structure as an organization. So you can't include everybody because new people are going to come to a map that's already in progress. But making it so that it's collaborative, makes it so those people can get on the same page, literally the same, so we're all on the same map and understand it better. But B, they can contribute to it. They can say, well, I think, you know, this map is great, but it doesn't take my perspective into account. So I'm going to change everything based on my perspective. And now that perspective is now in the map. So they can kind of own the map by putting their perspective into the map, even if they weren't a part of creating the map in time, you know, for whatever reason, because you didn't include them or because they're new to the project or whatever. But clearly, it is incredibly important to get people involved in the creation of whatever it is that you're trying to get the collective to do or understand or whatever.
Okay, I think Claudia, if that's finished.
I'm in here. Can you hear me?
Yeah.
I have a question.
Yeah.
In the question about out of wedlock childbirth, the question I have is that as time has gone on, the relevance of the connection between wedlock and childbirth is weakening, and the nature of the question becomes different. I mean, there are people who decide they're going to have children independent of whether or not they're married, for none of the issues that are involved in the discussion of out of wedlock childbirth. They don't have a problem. So we have set ourselves up with a problem, that the problem itself is disappearing because people are making decisions on different bases. Women are independent. Women are forming families because they, or maybe you're not, because they don't have a relationship that satisfies them in a way that enables them to form a family out of it. You know what I'm saying? Not saying that they're gay, but there may be that they are gay and they're forming their family with, you know, and then the possibility to be married as a gay person has evolved over time. So the sociological context is evolving in the that surrounds the problem, such that the problem doesn't become is less of a problem. We're defining problems that don't exist. Is the problem I'm trying to get at in the way this question is structured.
Yeah, that's a great point. I mean, this example that we gave you was from the mid-1990s, where we were dealing with rising rates in teens and women without means. Now the picture has changed, which is why we need new other policies, especially around marriage, and property rights and lots of other things. And I would say that the problem still exists, but you're right also that the problem is evolving and there are new problems. And that those new problems, that new evolving context will change the distinctions that we were making. So that map has to evolve. These maps have to constantly evolve based on those new perspectives. So someone like what you're saying could come into that map and say, I challenge all these distinctions based on the new perspective. All these distinctions should be tossed. And here are the ones that I should replace, that I would recommend replacing them with. And when we replace those distinctions, we see different systems, we see different relationships from this new perspective. And very soon, not too long from now, there'll be an evolution function in the maps where you can drag a slider and actually see the maps evolve so that you can see them at different stages and then and then evolve them. And you can see the different perspectives at different stages in the evolution. Mm-hmm. But you're absolutely right. I mean, nothing is static.
Thank you. That's good. Thank you.
I have kind of a related question. So which kind of a, like this process of evolution, which makes framing our problem very important. So like when we say we want to draw a system map, so what are you drawing it for? So what is your experience been with how to frame the question in a way that can engage and that describe our situation precisely and also engage the audience? Like my experience has been a lot of times we have only a vague idea of what we want to do. We kind of have to go through a process with the entire group to define the problem in a way that captures everybody's opinion. I want to kind of see what's your insight on this.
Yeah, I think that's a great example. And I would I mean, the metaphor of framing, which is a perspective language, right? When we frame things, we're using perspective, is critically important. If you think about literally framing a photograph, which happens first, the photograph or the frame? You know, maybe you have a frame so you get the photograph to fit it. Maybe you have a photograph so you get the frame to fit it. It can happen and it can change over time, right? So what I've noticed is that people need to frame more, and they need to make the explicit perspectives of the frame more explicit because they're often implicit. Mapping allows you to do that because it allows you to make the perspectives explicit. But you're right that framing evolves as you're analyzing. So as you're getting into the map, you're changing the frame, and collaboratively the frame is changing as well. And over time, you just have to be committed to getting the accuracy of that frame, whether it happens on the front end or whether it happens as an emergent property of the analysis is up to you and up to the process. It typically happens both, is the answer. But over time, you get a more clear frame, and that framing has to be part of the analysis. And what I notice is we do a lot of analysis that doesn't tell us what the framing was that led to it. The perspectives, and another way of saying that is the perspectives are implicit and the analysis is explicit. And what I'm saying in systems thinking is the perspectives and the analysis has to be explicit for the exact reason that Claudia just mentioned, which is when things change, we want to change the frame. And we want to say, well, this was the explicit frame that led to this analysis, but now it looks like the frame has changed, so the analysis will change too. And here's how.
Okay.
Does that make sense?
Yes, absolutely. Very, very insightful.
So part of the reason the concept mapping or the systems mapping is so critical is that it's object oriented. So if something exists, it will be an object. It'll be a card. So if a perspective exists in creating the analysis, then that perspective should be in the map with the analysis.
And both need to be explicit.
Yes.
Am I still on?
Yeah, go ahead, Claudia.
We have perspectives on families that are so embedded in our social context that it's difficult to frame a question that's not dependent on the continuation of that social context. If we ask ourselves how best to care for children, then I don't know your system that you're using, but the question of whether or not the parents of the children are married might be a card in the system somewhere, but it wouldn't be the central question because the children are going to be there independently of all that other stuff. You know what I'm saying? Does your system allow for the evolution of that kind of outcome, where the limiting perspectives disappear over time through the analysis?
It not only allows for it, it very much encourages it. The whole point of distinction, identity, other, is that when we lay down an identity, that we consider the other. What we tend to do is we mistake or we conflate the distinction with the identity. We think that the identity that we lay down in our analysis is the distinction, but it's not. The distinction is the dividing line between the identity and the other. So in distinction making, what we're doing is we're acknowledging that a bunch of distinctions are being made that are deeply implicating perspectives, even though they might not be saying the perspectives that they're coming from, but they're highly biased. And we have to think about the other at every one of those distinction points. Now, in systems thinking, in the past, in the 1950s, 60s, 70s, even 80s and 90s, the boundary condition of that distinction was mostly the external boundary of the system itself. What DSRP is saying is there's a boundary condition around every single element. Every single element has an identity other boundary distinction, not just the system of what's in it and out of it, but every element in the system is a distinct identity that has an other possibility. And we have to consider those other possibilities in order to pay attention to our possible biases, which is exactly what you're saying. I could lay down what seems like an innocuous word, and you know, your head could explode and go, you're kidding me, right? Like, you think that's an innocuous word? But that's crazy. That's so loaded with perspective that we can't just accept that word as a commonplace word. It's incredibly loaded with perspective.
Yeah. Interesting. Thank you.
Derek, I see that in the DSRP, each of them is you have two different things in there. It's like the system and the part, the point and the view.
Yeah.
So I find this very, very interesting and very good because it's like because I'm a traditional Chinese medicine practitioner, so I use this yin and yang and 5 elements all the time, and I find that it's all over your system. I just wonder, how did you come up with two of this in each of the DSRP? This will be interesting how you come up with this idea.
That's a very good question, and it's a question that it has kind of a short answer and a really, really long answer. One part of it is DSRP is a mathematical formalism, but you don't need to understand any of the math to use it. That's why we developed the software that's object oriented. But each one of the DSRP elements is made up of two patterns, is made up of two elements. And those two elements are in a relationship. And those two elements related form a system. And both of the elements can have a perspective. And what that means, and both of the elements and the relationship are distinguished. What that means is that in order to do a D, or an S, or an R, or a P, you actually need D, S, R, and P. That's kind of hard, like that's hard to get your head around, that in order to make a single distinction, you have to take a perspective, you have to make a relationship between identity other. When you make that relationship between identity other, you're creating a little system, a part-whole system that is that distinction. In other words, there's what's called mathematical enclosure around the four things. And the answer to your question actually explains why there's only four. And a lot of people ask, why isn't there, maybe there's 5, or maybe there's 3, or maybe there's 27. And it turns out there's not, because of this mathematical enclosure. You don't need anything else to make what you need to make. You just need these things.
They're like dimensions.
Yeah. Sorry, say that again?
They're like dimensions.
Yeah, they're functions.
And if they span the space, they span the space.
Yes.
And there's no more that you would need.
So hopefully that didn't confuse you, because I don't want to confuse you and make it seem more hard than it is. But that is
it's very good.
It's very important, actually, to the theory and the mathematics of the theory.
Sounds like that could be another presentation, Derek.
Yeah, I could teach a whole year on that, on that question alone.
Well, we're down.
So you mean is what's behind all your theory? You actually build on mathematics. Is that what you're talking about? What do you mean by building on mathematics? You mean you have got a mathematical representation of it, or how does it relate to mathematics? That's what I want to know.
I guess the simple way to answer it in a very short amount of time that we have is to say, in systems thinking, as the title of the talk and of today's talk sort of and the description suggested, I think the biggest problem in systems thinking today isn't the concepts of systems thinking, but the doing of it. And not just the doing of it, but the making the doing of it accessible to anyone and everyone. In order to do that, our definition of systems thinking has to be such that it is object-oriented enough that these things can be parsed, that when you get down to the very essence of them, they don't end up being the same thing. And the software is a great example of that. The fact that we can program software to do DSRP means that it is manifestable. It's not just like hand waving. It's something that we can actually do and manifest in code and in visuals and in things. And that's what I mean by mathematical. It's just, it is so precise at a level that it allows us to do some things that we wouldn't otherwise be able to do without that precision. And that might sound like a crazy answer, but the net effect is it allows kindergartners to learn systems thinking. It allows 8th graders to learn systems thinking because they can map it. And they don't even have to know the words DSRP. They don't even have to be able to form those words in their mouth. They could be 2 years old and start structurally mapping by just clicking and moving things and stuff like that. And that structural mapping will help them to become systems thinkers.
Yep, that's very good. That's very important. I very much agree with your idea. Thanks.
I have a feeling Thomas is tracking with your math. So anyway, thank you, Derek. We're down to the overtime.
Yeah, sorry.
No. It was a great discussion and a great presentation, and we just really appreciate you being willing to do this and give us time. So yeah,
Thank you.
good.
Thank
Yes,
you so much. Appreciate it.
And we'll send out some information to the group that attended, follow-up information later, probably tomorrow.
Yeah, and if any of you ever need any help mapping or whatever, feel free to contact us, and we'll give you examples or show you, because our thing is we want systems thinking to be available to anyone and anyone who wants to do it, and not something that you have to spend your whole life studying in order to understand, because only a few of us are lucky enough to just spend your life contemplating what systems thinking is.
Exactly.
So, thank you very much.
Yeah, you're welcome. Goodbye, everybody.
Thanks,
Bye.
Thanks for putting this together.
Yeah, sure.
Thank you. How do I get out of this?